Okay, if you don't have a drink, just try out the Tweet for Beer. I heard it's performing and it's working, and just use our hashtags and the Tweet for Beer, and you get a fresh beer or Coke or whatever. Before I introduce the next speaker, all the talks are going to be recorded and the slides are online. So if you're not quite sure which track you want to attend, you can all see the videos of the presentations afterwards online, of course. And now it's an honor flying in from San Francisco. Indy on stage. He works for Google on the photo app for Android. And without further ado, I hand over to you.
All right. Thank you. Hi, everyone. My name is Indy. I work at this little company called Google. You may have heard of it. And I'm the tech lead and manager of the Android app. And this conference came at a really good time because we just launched a new Photos app 2 weeks ago at I/O. So I can talk about it now. So I wasn't sure if all the launch and everything would line up perfectly. So I've been building mobile apps for a really long time. So I'll give you a brief history. So I started working on mobile apps in 2008. So we launched apps on the first day the iOS App Store opened with a little mobile social network called Zintin. And from there, we released a bunch of apps, including Scribble, which was the first free drawing app on iOS. It was really popular at the time. Then I decided to get a real job and started working at a company called Bump. So this was a startup where you'd bump two phones together and you could exchange contacts and photos. So I joined to build their 2.0 and then later 3.0 iOS and Android apps. So I got to work on both platforms there. And then we later built an app called Flock, which was an app to help you share photos with the people you're taking photos with at the moment. So doing iOS and Android there for a while. And then we got acquired by Google, worked on Google Plus for a little while, and for the past year, I've been leading the Android team for photos. So, great, lots of apps. Why do you care? The nice thing is I've been lucky enough to be working in the modern app space since the very beginning, essentially. And I've also been lucky enough to build almost all of these apps up there from scratch. So that's given me a perspective on things that you need top to bottom when you're designing the app all the way to iterating on the app. So I just wanted to use this time to share a few things that I've learned that I feel like I've had to rebuild or know every time I built an app. So I've broken down my learnings into three categories. So first is designing your app, what you should do when you're initially thinking about it. Building the app, and then iterating on it once you've launched. So I'll start with designing first. And so the most important thing when you're working on an app versus a larger product in some way is that you have to do a few things. You only have to do and only pick a couple things. So what happens with mobile apps is each icon on the screen, people think of it as separate, unique features or things that they're trying to do. So you don't want your app to be everything. So for example, if you go to Facebook, you've got the chat window right there as well as the social stream and all these things. And that's on a large screen with a lot of space. But when you're talking about apps, you want to only do a few things and you want to do them well. So again, I'll pick on Facebook here. A few years ago, they split out their Messenger product from their main app. And that's because they weren't able to focus on either one well. Particularly, Messenger was just a feature within the Facebook app. So once they split it out, made it a separate app, they could focus on it, build it better, and it's now one of the most popular messaging apps they have. So yes, make sure you're focusing on a few things at a time. The app is a single unit of functionality. And then once you've figured out what you want to build, focus on the UX first. It's really easy when you have a great idea to be like, okay, cool, now I'm going to go right into Photoshop, start mocking things up, put something on Dribbble, get a bunch of likes. But you forget why you're actually building what you're building. So it's important to do a few early prototypes, go out, do some user testing. So we use some pretty cheap mechanisms in the past. You post something on Craigslist, you build a little prototype with just paper, you bring people in, they tap on paper, and you just switch things out. But you want to get a sense of the workflow that your users are going to have in your app, rather than building the prettiest thing as soon as possible. So focus on the UX first. It's really important to get your workflows right, and the UI can follow from that. Once you know what works for people, you can make things prettier. You can have the nice colors and transitions. And lastly, the progress spinner. This is your enemy. Anytime you're seeing this on the app, you're waiting. Your users are waiting, and you want to avoid this as much as possible. So there's obviously a lot you have to do when you're building the app to avoid this, but it's really important to think about this on the design stage of your app too. So there's apps that only work when you have connectivity or data. So a good example of that these days is Uber or Hotels Tonight. You need to have all this data from what cars are nearby and everything. But even with those apps, you can start showing things to people early. You can start showing them on the map before you have all the car data or anything like that. So at Bump, a good example for this was Bump only worked when you had connectivities to our servers. So if the two phones tried to bump together and one wasn't connected, it wouldn't work. But we didn't want to stop users from using the app while this connectivity was happening. So what we did was we front-loaded the picking workflow. So if you wanted to share a couple photos, we built the picker, and you could go through and start picking photos even before you were connected to the servers. So usually by the time you're done picking what you want to share, you're good to go. So think about avoiding the spinner right in the design phase. See what you can do to move things around. So as I said, it's not just about design to avoid this. You have to think about it when you're building it as well. So I'm going to go over what I jokingly call the one true architecture. There's no such thing. But this is something I just wanted to outline a few things I've come to build over and over every time we built a new app. So I'll give you a quick overview of what this is. So it's really simple. You've got your UI layer. Your UI layer talks to the data layer by registering for updates, and then it just receives updates as the data is ready. Look, it's pretty straightforward. Some of you will be like, I've seen this before. This is MVC. And it is MVC, but there's a few important refinements that you need to think about when you're working with mobile apps, and I want to dig into those. So let's focus on the UI side first. So what is the UI, first of all? It's your UI view controller on iOS, or activities or fragments. These are the things that are reacting to user input. So anytime a user presses a button or picks something, it's all mediated by a UI view controller or a fragment. But the fragment's job is to take the data, munge it into something that the view needs to display or react to that. Its job isn't to do a network call or hit the database directly. And this is a failure mode I've seen a lot of apps do architecturally, where you have these classes, these controller classes, hitting the database directly. And when you start doing things like that, you lose out on the abstraction that'll let you do intelligent caching across different strains in your app. So you want to avoid that. And so all of the data, as I said, is mediated by the data management layer. So register for the updates and receive the updates rather than very explicitly doing anything. So what does this data management layer look like? So as I said, one of the important parts of this to avoid that progress spinner is having some sort of local cache. So you're working with native code. You have an enormous amount of cache space that you normally won't have when you're building a web front end. So use that data, use that power that you have, and so you can have people. So your users can have data to look at immediately. This is particularly great for like social networks or things like that when you have a stream of data. So even though you may not have the freshest data, you can store the last few items of the stream that are supposed to be visible to the user, so they can have it ready for them immediately as soon as they open the app, so they're not spinning and waiting for new things to come up. But great, so you have local data servers. I'm talking about, hey, you should just don't do any network requests or don't do any database requests. How are you actually going to get the data? So you have to sync your data at some point. So obviously, there are going to be some UI requests. The first time a user opens the app, you're going to have to hit the network. There are UI interactions like the pull to refresh that's pretty common in a lot of apps where you'll have to do a refresh. So you have to obviously be ready for those. But a few other things, you generally want to be ready for the user before they actually have to do anything. So one of these cases is push notifications. So if you get a notification on your phone, ideally the payload for the notification you're sending from your server to your device has all the pieces of data that they would need to display the information when they open the app. So you're not doing another fetch when you open the app. Sometimes this isn't necessary. So when you get these notifications, and now also in iOS, I believe you can get a hook that'll wake your app up, and your app can do some background requests to get all the data that's necessary. So by the time the user taps on that notification, you're good to go. So that's one thing you should be careful about. You should try to prefetch. And lastly, use low priority background jobs. So this is particularly useful. Let's say you're building a newsreader, and every morning someone wakes up and they want the freshest news in their app. So instead of having that fetch happen triggered on when the app is opened, do it in the background. Now, I say low priority background jobs here because you have to be very careful about battery life. It's really easy, particularly on Android, where you have so much flexibility to say, oh yeah, I'm just going to fetch data every 2 hours. But the problem with that is you'll just burn through people's data plans or battery life in particular. So starting up the network radio on all of these phones is actually quite costly. So you want to avoid doing that as much as possible. Now, with the latest versions of iOS, they give you just a general background task handler. With Android in, I believe, L, they expose a job scheduler API, which will wake you up when the network radio is already on, so your app isn't the one triggering it, and then you're not wasting extra battery life. In older operating systems in Android, you can use something called a sync adapter. So great. So that's the architecture I wanted to show you. So all of this is in service of avoiding that spinner, right? You want to make sure things are fast and easy to use for people. But the other part of your app is almost always scrolling. So this is any app that you're working on, you'll have a list, and you're scrolling, and you want users to be able to fling through it and just see a whole bunch of data really quickly. And this is always a pain. Both iOS and Android, the frameworks give you some nice APIs with the UI collection view or recycler view. But these frameworks, even though they do a lot of nice things for you, like pre-allocate views and recycle them as you're scrolling, they don't know how your app works. So if the rendering of certain data requires fetching large images or doing a special type of drawing of text that could be costly, the OS can't just automatically optimize that for you. So this is one of those things that you just have to spend time on looking at the trace view for each platform and just look at what's taking time as users are scrolling. And here I'll make a plug for this library called Glide that we use on the Photos app at Google, as well as we use this at Bump. And this app, this library is primarily for dealing with images in large scroll views. So it does a lot of the heavy lifting when you're dealing with large numbers of images in a scroll view. So it does things like pooling bitmaps, which is really important in older versions of Android, where a cost of allocating things was really high, and the garbage collector would basically stop your app. So as you're scrolling, suddenly your whole phone would be frozen, and then things would move. So if you pool bitmaps, you can reuse them and not have this jank that you see. It does lots of other really nice things, like canceling network requests. If you fling through lots of images really fast, it'll request those images, but if they go off the screen before the user can get a chance to even see it, it'll cancel the network request for you. It has hooks to help you do that. And it also does some pretty cool things like progressive loading of images. So you can say, hey, I want a smaller, blurrier version of the image to show up first, so you have something showing up right away, and then load it with a larger image later. So use this library if you're dealing with lots of images. We love it. It's been very helpful. It's actually maintained by one of the members on our team called Sam Judd, so try it out. Cool. So one of the other questions I get a lot about having built so many apps is code sharing. And this is a pain you run into pretty quickly if you're starting to build iOS and Android apps. You feel like, I just built this thing. I'm going to have to build the same exact thing again. You write the code, and I'm like, you feel like a human translator from Objective-C to Java or Java to Objective-C, and you want to try to figure out what the best way to share code is. So I'm going to go over 3 approaches that I've seen, and just go through pros and cons. And different approaches could be good or bad for you depending on what app you're building. I have my biases, and you'll see them. So first is web view containers. So especially when this was very popular when the app stores first opened. People already knew how web worked, how web technologies worked. So all they did was like, well, we're just going to put it in a container and just ship the app. And that just never works out well. Your scrolling performance is never as great. The UI is just slightly sluggish. It doesn't actually match the platform, or let's say you end up focusing, you build the UI with iOS in mind, and it doesn't really fit Android, and Android users feel like they're using this weird Bizarro app. So this approach has not always been that great. There are tools that help you make a lot of this better, though. PhoneGap has been one of them. But in general, because of UI differences between platforms, this tends to not feel as good or as native to each platform. So the other approach I've seen is code compilers. So this is when you write all your code in one language, and it either translates to the other, so it's from Java to Objective-C or something. I don't think I've ever seen Objective-C to Java, or some third language that compiles to both. And this has its pros and cons. I've seen some really great success stories, but there are some pitfalls. So I'll start with the negatives here. The negative with code compilers is, if one platform creates a new API that you want to use, you have to wait for whatever this code compiler is that you're using to be ready, to have updates to use those things before you can use that new API. And usually, in this apps world, you want to stay up to date with the latest API, so you're building the smoothest, fastest, most interesting UIs for people. So these things tend to be a little further behind. Where I have seen this work out well, though, is with the data management layer, because often their Objective-C and Java are not that different in terms of their fundamentally how they work. So if you're talking about how your objects are, what your data model looks like and how it gets transformed throughout various pieces of your app, you can just do that in one of these common languages. Which brings me to my third way of doing these things, and this is shared native code. And this is the thing that I've personally used and had great success with. So we, at Bump and with Flock, we use this exclusively for our data management layer. So in particular, I'll give you the example of the Flock app. The Flock we built first for iOS. The entire data management layer was all in C. or all of our network code was in C. And when it was time to build the Android app, we built it in a hackathon. We built the entire UI around it in 2 days because we had a solid working core already, and we could just drop it in a new place and build a new UI. The really nice thing about this approach is you get something solid that gets tested on both platforms, and you're building a UI that's native to each platform. And this makes sure you're using the latest framework APIs to help you build a better app. So this worked out really well for us. Definitely the downsides here are, you have to now work in a third language or native code. There's, particularly with Android, you have to deal with bridging native code and Android and Java, so you use JNI. Whereas in iOS, you can have Objective-C directly talk to native code. There's a couple things that are out there to help you with that. So Dropbox recently launched an open source project called Genie, I believe is how they pronounce it. And it's DJNI, I think. And what we use at Bump was actually use an in-process socket. So we actually treated this as a separate microservice in a way, running within our own process. So you would have a socket that's open on either end to push data up to the UI layer or send requests down to the data management layer. Great. You've built the app. You know how to avoid progress spinners. You're good. It's time to launch. You've launched. Now what? First thing you have to worry about is crashes. And crashes suck. They're horrible. This will happen though, right? You have to deal with it, and you have to find a way to deal with it. This is one of the downsides of building native apps, especially user-facing apps, where if you have something bad in your workflow as the user is using it, the app completely disappears. On the server, you can have some daemons running that'll auto-start things for you, but with native user-facing apps, this is something you have to worry about. So how do you keep track of these? Well, if you can, if your privacy policy and if you have the resources, try to log everything, all the crashes that happen. So you can strip out a lot of things and just get the raw Java trace or the raw Objective-C trace of your crash. And make sure you have these all logged, and so you can run some analysis on this. So in particular, the number that I like to always look at is crash rate, which is how many crashes are happening per user session. And I have this less than 2% up there. That's because, in my experience, if this number ever grows above 2, you will get lots of nasty reports and user feedback on the Play Store. People say, "Oh, this is a completely crashy app. I can't believe you released this garbage." Things like that. And you have to be so you want to be very mindful of this crash rate and try to reduce it. So 2% should be your rough goal there, but really it's more than just the user feedback is the reason you should reduce it. You should aim for something a lot lower. And if you're logging all your crashes, you can just go down from the most frequent to the least frequent and just make your way through with updates to your app. And once you have this data, it's really easy to find those problems. There's almost some stupid null pointer exception in Java, and you can just fix it and move on, right? But this isn't the entire story. This is just an aggregate number for all crashes for your app. What you really want is to break this down for different device types, particularly for Android, because there's thousands of different device types that are out there. So what I like to have is what we call Crash Dash. So it breaks down your crashes for your app between different device types. So these are completely made up numbers. I'm not saying that one platform is better or worse than the other. But it's just an illustration of the kind of things you'll see. So as you can see here, the Samsung devices seem to be doing decent. Okay, we're at 1.4, 1.6% crash rates there. Nexus 5, for some reason, is a little higher. But the thing that sticks out here is 8.8. that's a really big crash rate number. Like that's going to be, you'll probably see HTC, in this case, an HTC user complain in your ratings when you have something that bad. So it's really nice to have this because you will have this sort of stuff happen. There will be some popular device that you don't own, that you haven't tested on, that will be crashing in some strange way. So it's nice to know which ones you can focus in on. So make sure you have something that can break things down this way. And the nice thing is, if you're logging all of your actual traces, you can then break it down by this device, and you will very quickly find, if you just filter on this HTC device here, what the crash is, and you can again probably fix it because it's probably some other dumb Java like null pointer exception. So next, after you've launched, so crashes are always of the utmost importance because if your app's crashing, no one's using it, none of the other metrics really matter. Next, I'll talk about user ratings. So by the way, if you ever get to this many stars, you're doing really well. So both Apple and iOS and the Android stores, they both have a 5-star rating system. And what you'll notice about this, though, is ratings are almost always biased towards people that are complaining about your app. So it's okay to give them a gentle nudge in your app to rate your app well. So, and I say gentle because lots of apps can get pretty aggressive about this, and it gets into your workflow. First and foremost, you want to let people actually use your app rather than have them rate something. So find some workflow in your app where they've completed some task and it worked well. They finished something. The workflow is done, and add something small, gentle in the workflow rather than a big blocking dialogue to ask people, hey, like, seems like you completed things nicely here. Do you want to rate our app a little better? So it's okay, in my opinion, to do a gentle nudge to help people rate your app better, because this is important for new users coming into your app. They'll look at this rating, and if this rating becomes particularly less than 4, quite a bit less than 4, then they will look at their user reviews and they will find all those negative things. So you want to try to balance these things out. And I want to talk about user feedback. It's all related. Ratings and feedbacks, the 5-star ratings and feedback do go hand in hand. But I want to focus in on feedback specifically. This is the words people type on feedback for you. And this can be very valuable. Your users are taking time out of their day to actually tell you about what they like or don't like about your app. So listen to it, read it. You'll learn a lot about your app. Even though, as I talked earlier in the design phase, if you've done all this user testing, you will probably have learned different workflows for users, but you may not realize what people are using your app for. And the user feedback is a great way to learn that. But it's, again, something you should be careful about in mind and read carefully. So if people have complaints about your app, they will propose a solution. And it's really easy to see that. I'm like, oh yeah, we should do that, and just start building it. But you have to be careful. Instead of just building the solution that the users are complaining about or asking for, try to figure out what the real problem is, and then go back to the design phase and understand how you can improve that. So it's always important to be just gut checking what people are saying in this user feedback. Cool. So you've got your user feedback, you've got your crashes, you've got your basics covered. Now let's talk about data. So you have to understand, in whatever app you've built, what the most important pieces of data are. So let's say you're building a photo sharing app. It's important for you to, so if I were to think about this, it's important for you to understand how many photos are being shared, how many users do people share photos with, how often do they share photos. All of these things are important to understand, right? So find that find that core mission. Go back to the very beginning when I said do one or two things well. Find those one or two things and make sure you have logging around it so you can break things down the way I just described. But I don't know what you're building, so I'm going to just talk about a few general numbers that you should be logging. Then these are just really important to know to understand how well your app's doing. So first I'm going to talk about engagement. So there's a number, there's this term called DN7, where 7 is the total number of days in a week, and N is just some number of days in a week that you pick. So this is usually the total number of users that are using the app N days a week divided by the total numbers of users in a week. So if you're building a utility, it's something people probably don't use that often. So the number you want to look for is D17 or D27. How are people using it once a week or twice a week? If you're building a social network, you probably want some really high engagement number, right? So, and some really high bar for yourself. So the number you probably look for is D67 or D77, where you want to make sure people are coming in day after day, and what percentage of people are actually doing that. So this is engagement. Take a look at this number for your app and find the right number for whatever you're building. Next is retention. So retention is essentially how many people show up to your app after they first tried it, right? So this is usually done as number of users that show up on day N after the first day they tried it. So you've probably seen this number. If you've actually released an iOS app and iTunes Connect, you've probably seen a chart that looks something like this. And this is actually based on that exact number, the retention number. So, the rows here are the day a user started on the app, and the columns are how many days in, what percentage of people are actually using the app. So with a matrix like this, you can very quickly get a sense of how well your app is evolving over time. So this is often called cohort analysis of your retention. So as you can see, the first 2 days seem to be behaving roughly the same. So the first couple of days, new users came in and they started dropping off at the same rate. On this third day, maybe something went wrong in your back end that day, and you were fighting a fire. People weren't getting updates quickly, so they thought the app wasn't that useful, and things just dropped off very quickly. And then on this fourth day, things are suddenly looking pretty good. So maybe you fixed your bug, but then you released a version of the app which gives people value immediately that they want to keep trying day in, day out. So things don't change that quickly. But I did put it up there as an illustration of the things that you should be looking for. And you can break this down not just by days. You can do this, often you want to do this based on experiments that you're running. So group A versus group B, even though they started on the same day, and how they're faring over time. So in all this iteration stuff that I'm talking about, you'll notice that there's a lot of numbers. There's crashes, crash rates divided by, split out by all the users you have. You've got engagement, retention, cohort analysis, all these things. But make sure you build dashboards for these things. And actually, you don't necessarily have to build them all. There's a lot of companies that'll do this for you, Mixpanel or Google Analytics or Crashlytics. All these companies, they do a lot of this work for you. But make sure you have this data, because I like to say that I hate flying blind. Every time I release an app, any update of an app, I don't want to be, I need to know what's going on. If I don't know what my engagement metrics or retention metrics are, if I don't know how often apps are crashing, I have no idea how well my app is doing on the market. Just reading user reviews and user feedback is just never enough for you to understand how well your app's actually doing. So make dashboards. There's lots of great tools out there. It's just going to make your life a lot easier and help you iterate faster. So that's all I've got. So this is sort of a distillation of just a bunch of random things I've learned over time. And I hope you guys learned something, and I want to just open it up for questions and comments and maybe learn something from you guys. So, thanks. Can someone bring a mic up here? Yeah.
You didn't tell that much about like your directly using the libraries in Google Photos, for example.
Yeah.
So just one thing you mentioned was Glide as a library. Have you ever thought also of using like Picasso or something? So
yeah. So we actually looked at Picasso very early on, and it wasn't right for. This was at Bump, so it wasn't right for a use case. That's why we built Glide. It was supposed to be an alternative to Picasso. But I've heard great things about Picasso from lots of other people. They've definitely used that. Glide over time is evolving to have a lot more very specifically image loading features that are not all available in Picasso. So, it's something that we're actively working on because we are the default Photos app for Android. We're putting a lot of work into it, and it's open source, so you can use it too. So yeah, but Picasso is also a great alternative. I think it just has fewer features than we need. Yeah.
Okay, and just another question. Can you give a brief overview of all the libraries, for example, you're using in the Photos app, especially also like for crash reporting?
So everything is custom. Like at Google, there's very few services that we use that are not Google specific. Glide was the only open source thing that we have, and that's why I mentioned it. But as I mentioned, if you're a third-party developer, there's a lot of tools out there that'll do that for you. I believe Crashlytics is a good one that people use to manage do crash reporting. If you are going to go build it custom, it's actually pretty straightforward to do as well. You can just add a top-level exception handler to all of your threads on both iOS and Android, and just capture the report, have it stored, and send it up to your server whenever you get connectivity again. So, but yeah, it's all very custom. We're not using any third-party service.
And is there a reason for that? I mean, why build something?
Yeah, it's because we've built this already. So there's a lot of great infrastructure that's very specific to how we do things within Google. So Google's a pretty big company. There's, as I was talking to Dav earlier, some of the image loading stuff is something Google's built for itself for a long time. So we just leverage the tools that work with our backends and our infrastructure quite a bit. Yeah.
How do you deal with the different speed of development of mobile and backends? For example, if you do you try to keep the same pace of releases, or do you try to somehow synchronize them?
Yeah, this is a very good question. I used to do web stuff before all of this, and very much love the ability to press a button. All the updates are out there, right? And it's just not the same with mobile apps. So to deal with that, you essentially have to be releasing as fast as possible on all platforms, right? So that usually ends up being about 2 weeks at about its fastest for mobile apps. So an update every 2 weeks. You could push aggressively on Android if you wanted, but it is 2 weeks ends up being the most comfortable pace that I've seen across different teams. So the question about how you deal with the differences between these release cycles, because on the back end that you're building, you can update things quickly. It's all about making sure your APIs are set correctly. You design them thoughtfully. So even though you're improving your APIs on the back end, your app's still talking the same APIs, and you're in good shape. So yeah, it's just all about doing a little bit of the pre-work to make sure your API is solid. Some questions back there.
So you talked a bit about code sharing between iOS and Android, and your preferred way was shared native code. What's your experience with dealing with user problem reports when the problems cross this barrier to the shared native code?
Okay. So iOS is a lot easier to deal with because it's essentially how iOS works. It gives you lots of the traces in a very readable format. On Android, you can get crashes that are native, and you get a little bit more of an obfuscated trace. So you can write some tools that'll go through and unobfuscate things for you. But yeah, that's a good question. There's no real good answer that I've come up with so far with that, particularly on the native crashes on the Android side. They always take a bit more work. But a lot of these things, you can look at just the unique data on like which line is crashing and things like that to group them together and try to get a sense of what's important. But yeah, the native crashing on Android in particular is pretty hard to deal with. I don't have a good answer.
And do you have any experience with the problems which happen on Android and do not happen on iOS, or the other way around?
For native code?
Yeah.
It's mostly with the communication layer. You just have to, there's a lot more work you have to do with Android because of bridging the Java virtual machine and native code. But yeah, in general, as I said, the part that we used it for was our data management layer. So that's just using, like it's essentially the same code. It's not like the C compilers and all these things are very well tested and very well put together. They've been around for a long time. So compiling for ARM versus x86 or all these other things actually is generally not an issue. Yeah.
Hi. I have some questions about UX. You have said you have made some paper prototypes and let your staff use it, and so you can change into to a better user case. But my question is, you said you gave people to use it. The people is just your staff, your designer, or the actual user, your custom?
Yeah, that's a really good question. So your staff is not the right group of people to be testing your prototypes with. They think about the app every day, and they'll just have a completely skewed view of how things work. So what I've seen done is just ask on Craigslist or some other local classified service to see if people want to come in and test. What I've seen work basically the best is going into a bar because people are partially impaired already. And when they're using your app in real life, they're probably not paying that much attention to it as if you bring them in a lab and have them look at something. So like take your prototype, go into a bar and like try to convince someone to try your app, and then you will see how someone's not like really paying that much attention to things will actually fare on your app.
Okay. Yeah. Thank you.
Hi. My questions are pretty general, but what is the general team structure? For example, take Photos app, like how many designers work with developers? Because from my understanding, Google works with small teams.
Yeah.
And yeah.
So, so let's see. So the Android team that I run is it's growing. So I'm not sure of the exact number these days, but it's around 16 now. But we started with when we started building the app about a year ago, we were around 7 or 8, and it's been growing since then. iOS team similar in terms of size. The design team is I believe 5 or 6 people. And then we have a pretty large backend, and in particular, like a lot of the image analysis stuff and the image intelligence stuff is a larger team. Yeah.
Just a second question, like how do you see, because now Swift is getting open source, so would you guys dive into Swift and see what cool things are they doing and maybe replicate? Or do you feel like there would be a surge of migration from Android developers to Swift? Because now maybe you can learn, you don't need a Mac anymore for developers, maybe.
I don't think you can avoid that anytime soon. The way iOS apps work is you have to have, it's more than just the language, right? You have to have all of the other ecosystem and infrastructure around it, and that's still just built into Xcode, even though Swift is open source. The question about Android developers switching to iOS, I don't think the choice of language or platform in that way is the real reason people choose to do one thing or the other. I chose to start working on mobile apps because I realized mobile apps were the future for user interaction, at least future for some number of years, right? It's not because I really wanted to program in Objective-C that I started working on iOS. So your choice, the reason you make those choices are not necessarily how nice the language is. On the mobile app side. Obviously, on the back end, you have your picking of working with your favorite apps, favorite languages and frameworks. So,
Thanks.
On the Android environment, my question is about unit testing. Where would you say is the best place to apply the most effort and why?
Yeah. First of all, there's a great framework called RoboElectric out there, which mocks out a lot of large parts of the Android framework. So you can then use JUnit and just run your tests as you're used to with other Java code. But in terms of like what's the important things to test, so one of the ways we built the Android app is to treat each segment of code as its own mini library with its own API. And it's important to test the API layer far more than the actual individual functions. And you can get the same coverage pretty quickly from that. And you really do want to be testing the APIs and making sure they're stable and still behaving the same rather than what individual functions are. So there's a balance to be played in what the most valuable thing to do with unit testing is. It's not always just getting the highest code coverage number. You want to make sure your API is well tested and behaves the same across changes. So.
Hi. So when you do the first few sessions of user testing, you realize that there's some things which don't work for you, and then you go back and think about them. You find a solution. And then when you go back and try to do a second session of the same thing, you start to realize there's more of it. So when do you actually stop freezing things and saying, this is the point I'm going to, actually start developing it?
Yeah, I mean, it depends. I mean, after a couple sessions of iteration, you converge pretty quickly. You rarely going on like 5 or 10 different iterations on your design stage between user testing and back. And you actually can get feedback really quickly. So when you're doing user testing, doing it with about 5 people, you will get all the data you'll get if you tested with that same prototype with more people. So you can actually tighten that loop pretty quickly. So in my experience, like, you should be thoughtful about even your first iteration and do your user testing to refine it further and get to a good place pretty quickly. You tend not to be in a long design stage for too many apps. Especially now, over time, there's a lot more common design patterns for mobile apps that you can use. So, yeah.
Hi, so my question is about the shared code stuff. Let's say you start with iOS and then you build this data layer. At some point, you'll have to duplicate it for Android. And at some point in the future, you have to make changes because, I don't know, your data model changes.
Yeah.
How do you sort of keep them in sync? Like, are there like just one code base for everything, or?
Yeah, the shared code is called shared code for a reason. It is actually shared. It is the same code base. It is the same repository. The C code is just a dependency from the iOS and Android. So as you're updating those, you should have tests, integration tests that are also building the other apps, and they'll break pretty quickly if you make a change that doesn't work for one platform or the other. So,
Thanks.
yeah. Cool. Yeah.
What development processes are you using? Are you working with Scrum or?
So I was having this discussion last night. Process, you shouldn't have your people fit into a process. You should have your process fit the people that you're on. So every team I've worked on, things were slightly different. But yeah, I tend to use Scrum tools as often as I can because it gives you a nice framework to iterate on and learn from things. So like almost always a daily stand-up's pretty useful. People on the team can quickly raise issues that other people might know about and then do a separate conversation later, even as the team's growing. But yeah, just like it depends on your people, your culture, and you have to pick and choose the parts that you've seen work before, and that would work with your group of people. So.
Can you tell us a bit?
Sorry, where are you? Okay.
Can you tell us something about the glue between your backend and your front end, and how it, for example, compares to Google Cloud endpoints for App Engine?
So I haven't used Google Cloud endpoints for App Engine myself, but I mean, in the end, there's two different things here. At Bump, we actually built our own custom protocol because right on top of TCP, because we needed to be connected and have an open connection to our server, work really quickly and be ready to go immediately. So that was very specific to how that app worked. So that was very custom, and even the backend was completely custom there. But with with most apps that you'll end up building, you're not doing that. You're using some HTTP or HTTPS API. So as I said earlier, just be thoughtful about what those APIs should be. Lock them down early in your development process if you can. But be flexible to just iterate on it with your team. And hopefully you're releasing fast enough that if you want to deprecate an API and use a new one, you can introduce that in the next version, switch over quickly. So there's nothing particularly magical about it. It's just being thoughtful about what your API should be.
And maybe a follow-up question. For support, do you go internal to other Android teams, or do you go to Stack Overflow?
Stack Overflow is great. I mean, if you can get an answer with the Google search, why need to ask other people, right? Yeah, I mean, definitely there is an advantage being at Google. You could ask, there's a lot of Android expertise around the company that you can ask. There's internal lists within the company, but Stack Overflow is usually the way to go. Yeah. Cool. All right. How are we doing on time? Are we good? Okay. Cool.
So if there are no more questions, last chance now? No? Cool. So then, thank you very much for your talk.
Yeah.
Big applause for Indy.
Thanks.